Sometimes our probabilities are experimental probabilities. We saw a video on that earlier on. Okay, so sometimes the data is given to us in a table, and maybe we've surveyed some people and we kept track whether they were male or female. We kept track about whether they were freshmen or sophomore students when we surveyed them. And the table maybe looks like this. So if we ask for the probability, if I draw a student at random from that hat over there, I want to know the probability that the student is male. So what I need on top is how many males were surveyed over how many total students we talked to. Now understand that the males are taken care of here in two different boxes. Here are the freshmen men and here were the sophomore men. And so altogether there are 23 males that were surveyed. Now I need to know the total number of students, which means I need to add up all four of these boxes. Okay, what I like to do when I'm given a table like this is go ahead and find all my totals all at once so that I have what I need and I don't have to run back and forth to the table and keep doing addition problems in the middle of the things I'm asked to do. So if we add 23 and 37, we get 60. You should double check that across 50, 60. Okay, whether I add it across horizontally or vertically, I should get the same total there. So that means 23 out of 30 total students, sorry, I said 30 but wrote 60. Total students would be the probability that that student would be male if I just drew one at random. If it asked what's the probability that that student is a sophomore, then if we look at the total number of sophomores that were surveyed on top and the total number of students that were surveyed on the bottom, 29 over 60 would be that probability. Maybe I want to know the probability that that student is a male or a freshman. Then we know if we're doing an either or situation, we can take the probability that the student was male, add it to the probability that the student, I guess I should have used sophomore, not that it matters here, but those are the two we already have written up there. The probability that the student was a sophomore. But then we have to subtract any overlap. And so if we look at the table at how many male sophomore students, there's our male freshman students, there's our male sophomore students. So the overlap between the male and the sophomore population was 11. So there's 40, 52, 41 out of 60 would be that probability. All right, so let's find the probability that the student is a female or a freshman. The probability that the student is a freshman or a sophomore. The probability that the student is male or a freshman, like we started to earlier. So if you want to pause the video here and compute those probabilities, do that at your desk at home. And then when you're ready, turn it back on and all the answers will be here. So don't turn it on until you're ready to see them. So there are 37 females, there are 31 freshmen, and there are 19 female freshmen. And so if we put those together, that's 49 over 60. There are 31 freshmen, there are 29 sophomores, there are no students that are both freshmen and sophomore students, which is 60 over 60, which is 1. Everybody, all students are either freshman or sophomore. It'd be the same if I said male or female. That would be all of them. Male or freshman is 23 and 31. There were 12 male freshmen, and so that is 42 over 60, and reduced is 21 over 30. Okay, let's say here's another table. We have students from Kansas or students not from Kansas. Those students were either athletes or not athletes while they attended the school here. I want you to find me the probability that if I draw a student at random, that student will either be from Kansas or be an athlete. I want you to find the probability that that student is not an athlete, just that single event. I want you to find me the probability that the student is not from Kansas. The probability that the student is from somewhere else other than Kansas. This is Kansas. Or is an athlete. How about just those 4 probabilities? So pause the video, use the table, see what you can come up with, turn it back on when you want to see the answers. Here are your probabilities. That the person is from Kansas, that they're an athlete from Kansas. Probability in general that they're not an athlete is this column here, 61 over 150. Probability that they're not from Kansas, we go straight across here, the 73 over 150. There's not Kansas. There's, yes, they're an athlete. Here are the not Kansas, but athlete students, and that one is the only one that reduces to lower terms. Here's our addition rule for probability.